Now, I want to give some examples of when it's appropriate to use the root and ratio tests. For example, let's look at a summation where my sum ends follow the formula n squared plus 1, all on 2 to the power n squared plus 1. And I'm going to raise that fraction then to the nth power. And I would like to know whether or not this series converges or diverges. So even though all of my sum ends are going to be positive fractions, plus 1, sorry, my convergence tests from last week might not be the most helpful thing, right? Am I going to compare this to the integral from 1 up to x of, let's say, t squared plus 1 on 2t squared plus 1, the whole quantity raised to the t power dt? No, that doesn't look like an antiderivative I want to mess with. The fact that I've got my formula raised to the power n here is sort of the giveaway that I want to use the ratio test. So just to be super clear, the formula for the nth number in my series is n squared plus 1, all on 2n squared plus 1, that whole fraction raised to the nth power. The limit test asks me to compute the limit as n goes to infinity of the nth root of a sub n. And boy, howdy, that'll be very easy to do here, since this formula is already raised to the nth power. So I'll be taking the limit as n goes to infinity of n squared plus 1, all on 2n squared plus 1. Now, you might already have a guess as to what that limit is going to tend towards, what that limit equals. But if I want to do it correctly, how do I make it obvious that this limit is tending towards, say, a half? I'm going to look for the largest power that occurs in my fraction, and that's n squared. I have an n squared on the numerator. I also have an n squared on the denominator. So I'm going to multiply, and I don't want to change the value of this fraction. I just want to rewrite its formula in a slightly more convenient way. So I can get that job done by multiplying on the numerator and denominator both by 1 divided by n squared. It's the same on the numerator and the denominator, so I don't actually change the value of this formula. I'm just shuffling things around a little bit. And how did I know it was n squared? That's because that's the largest power that I see in my formula. So this then becomes the limit of 1 plus 1 on n squared, all divided by 2 plus 1 on n squared. And as n goes to infinity, that numerator is going to look like 1 plus 0. That denominator is going to look like 2 plus 0, altogether 1/2. So that is the calculation I need to perform for the root test. Now is the interpretation. So I would say that my limit for the root test converged. Right? Not only did it converged to 1/2. What's the interpretation? Because 1/2 is less than 1, then the series must converge. So what are the outcomes for the root test? If the limit is equal, if this limit that I'm calculating here is less than 1, then the series that I'm interested in converges. If the limit is greater than 1, the series diverges. And if the limit equals 1, that's the edge case. That's not enough information. It could go either way. I would need to take a different test to figure out whether or not the series I want actually converges to a real number.